Hello friends, this question is from the test series 4 from the subjects of EMT and topic name is EM wave propagation theory. In the problem we have a uniform plane wave in air with an electric field as 8 cos omega t minus 4x minus 3z which is propagating in a y-axis. Is incident on a dielectric slab z greater than 0 which relative mu is 1 and epsilon naught relative epsilon r is 2.5 and sigma is 0. And we need to find out the angle of incidence first and the reflected electric field. So we need to find the two values, one is the angle of incidence, other one is the reflected electric field. So in the problem we have given the electric field expression of a propagating wave. So questions also says that angle of incidence which is given in the expression of electric field, which can be calculated by the expression of electric field as tan theta I is equal to bx by by, which is equal to 4 by 3. So by this, if you can take the tan inverse of this as 4 by 3, you can get the angle of incidence as 53.13 degrees. From the Snell's law, we know that the sin theta I is equal to n1 by n2 sin theta I of others medium. Or I can say that sin theta 1 is equal to n1 by n2 is equal to sin theta 2. So we know that this n1 is actually directly proportional to the 1 by under root of epsilon. So if you can put the value of incidence angle 53.13 and epsilon, then you can calculate the transmission angle theta t, which is equal to the 30.39. After that, we know that the wave is inciding in a perpendicular manner because the wave is propagating in a y direction and dielectric slab is in a z direction. It means our wave is in a perpendicular polarization. It is incident with a perpendicular polarization. So I can apply the R perpendicular with the expression as neta 2 cos theta I minus neta 1 cos theta t upon neta 2 cos theta I plus neta 1 cos theta t. Neta 1 is because the incident medium is air, so it is equal to 120 pi, and the other medium is not air, but for that medium we know that the value of mu r and epsilon naught r. So I can apply the expression of neta 2, which is epsilon r into epsilon naught mu r into mu naught upon epsilon r upon epsilon naught. We already know the value of under root of epsilon naught upon mu naught upon epsilon naught, which is 120 pi. And now if you can put the values of epsilon r as 1 and mu r as 1 and epsilon r as 2.5, then you can calculate the new value of neta 2, which is 238.4. Simple calculation. Now we know the angle of theta I, we know that angle of theta t, we already know that neta 1 and we have just calculated neta 2. So we can put all these four values. I can calculate the reflection coefficient perpendicular, R perpendicular. So by putting all these values, we have calculated R perpendicular as minus 0.389. So R perpendicular is nothing but E of other medium upon incidence electric field. So you can calculate our electric field at the second medium, which is perpendicular R perpendicular times EOI. We have just calculated the R perpendicular, which is minus 0.389. Magnitude of EOI we have already known, which is in our expression it is 8. So it is multiplied by the 8. Then the magnitude of other wave is minus 0.312. So the expression of the perpendicular electric field will be minus 3.112 cos 15 into 10 raised to power t minus 4x plus 3z. It is plus 3z because direction is reverse. Earlier it is going towards the z-axis, now it is going for the z-axis. So directly we will get the 1 plus sign because direction is opposite. So in this question our correct option is option A. Correct option is option A. Thank you.